Look, my handy dandy whiteboard. Look at this. Now realize that I am starting. First of all, I want to go around. I know Mr. Huth had me last semester. Mr. Bradshaw, you there?
Yep.
What? When was the last time you had calculus, and who did you have, or where did you take it?
Oh, well, I had Cal 1 with Marshall.
Okay, we already did this then, didn't we?
Yeah.
Yeah, okay, all right. So I remember I've got 2 or 3 people that haven't had calculus in a while, right? There's about 3 of y'all that maybe a year. So the calculus students that had Mr. Marshall within the last 6 months and had me in the last 6 months, I just want y'all to kind of jot down stuff and just kind of be patient, because I've got 3 or 4 people in here that maybe need to be brought up to speed. And I know you would want to be treated the same way if it was you, so that's what we'll do. All right, let's go ahead and start with basic factoring, go over a little review, and let's just start with something simple like x squared plus 4x plus 4. And that's pretty simple. There's several ways you can factor that. Just factor it however you want to. I'm going to turn off the front light so everybody can see. And x squared minus 3x minus 8, let's see, minus 18, you factor that. Basic factoring. Now when you're doing this basic factoring, you should be done probably in a minute, 30 seconds for each one. If it takes you like 2 or 3 hours, then you need to review a little bit. You can do both of them by reverse FOIL, or you can do the first one by shortcut number 1. Now, if you don't know what the shortcuts are, I will pull those up for you, and you can Google. Well, no, I can't do that because they're not called shortcuts. That's a Google term. Anyway, I'll put the shortcuts on the next board. Hold on. Let me just do that. The shortcut number 1, A plus B. Quantity squared is equal to a squared plus 2ab plus b squared. 2, a minus b quantity squared is equal to a squared minus 2ab plus b squared. 3, a squared minus b squared is equal to a plus b times a minus b. 4, a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And 5, a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Okay, that's the 5 shortcuts. You need to write them down and make sure you know them. Now, I call them shortcuts. I'm probably the only teacher that calls them shortcuts. So make sure you know what I'm talking about when I say shortcuts. I'm not going to call each one of them the difference of 2 squares, the sum of 2 squares, the difference of 2 cubes, or whatever. I'm not going to do all that. I'm just going to say shortcuts 1 through 5. I would say probably this and rationalizing the denominator are two of the biggest things that people forget when reviewing over algebra, is factoring and what did I say? Rationalizing the denominator. Mr. Patel came in and Miss Khalil came in, correct? Okay. Yeah, he finally decided he was in the wrong classroom. Were you in the wrong classroom? We thought you were in the classroom this whole time. What finally gave it away? Me not walking in or what? You just got to figure something was wrong. That's all right. We forgive you. Everybody, about half the class did the same thing.
Why did we change classrooms?
Because I wanted this classroom, because of this. This is the only room that has this in it. And nobody uses it. They put, Well, no, it works better. What I don't like is being in the classroom that I have to write on the wall with these. It doesn't work very well. And I've had so much training on it. I've had none. Yeah, Tri-County Tech, for those that don't know, they put these in like 2 days before the semester last fall. No training whatsoever. And then they wonder why teachers aren't using them. They don't know how to use them. So, duh. Okay, y'all got these down? All right. Let's go back to where we were. Can we do what? Oh, go right ahead. I'm sorry. Now, for those of you that have gotten them written down, go back to the first one and see if you can use the shortcut, which is shortcut number 1, and see if you can remember how to do it with the shortcut if you did it reverse FOIL. If you did it with the shortcut, then see if you can do it with the reverse FOIL. You need to be able to do both and not use one over the other. You should be able, when you see a perfect square like 4, 9, 16, 25, when you see that, you know it's a shortcut. Or it could be a shortcut depending on the signs. Got it? Okay. So, you see that this is a perfect square, and you see that this is a perfect square. Plus and plus gives you shortcut number 1. So you could go out shortcut number 1, and you can go down here and say, okay, that's going to be square root of x squared is x, and square root of 4 is 2, so that is your shortcut. So that's one way to do it. Or break up the first term starting with x. Break up the last term starting with 1, 2, and 2. So these two go together and these two go together because 1 times 4 will always give you 4. 2 times 2 will always give you 4. Now you're looking for a 4 right here. Well, 4 and 1 will give you a 5 or a 3. So 4 and 1 is out. So 2 and 2. This has to be the greater of the 2, so you just pick one because they're both the same, so that's plus. This means like or unlike. Like, so x plus 2, y squared. Should be the same answer. Okay, that's a review over shortcut number 1 as well as the reverse FOIL. Why is this one not a shortcut? Of what? What's not a perfect square? 18 is not a perfect square. How do you know that? Perfect squares. Everybody knows your multiplication table. Multiplication tables are 1, 4, 9, 16, 25. So you know those, and 18 is not there. So this guy right here says not a perfect square. So you got to go back to the reverse FOIL. Break up the first term starting with 1, which this is 1, so you can't mess that up. 18 is 1 times 18, 2 times 9, or 3 times what?
6.
3 times 6. 1 and 18 will give you a 19 or a 17. You want 3. 2 and 9 will give you an 11 or a 7. 6 and 3, that'll give you a 9 or a 3. You want a 3. So 3 and 6 is your number. This number is negative, so that means the biggest number has to be what? Negative. So the 6 is negative. This tells us like or unlike. Unlike, so this is positive. X plus 3 times x minus 6. Now, a lot of people say, what are you actually doing when you're factoring? Well, you're breaking it up into its multiples. Just remember 54. Factor 54. 6 times 9. You factor any term in algebra or math, and you break it up into its parts. A lot of people don't even know what the word factoring means. You're breaking it up. You're breaking a term up into its parts, its multiples. Well, that's what you're doing here. You're breaking this term up into its multiples. So think of it like a square. You know, some of this new core, common core crap, whatever it's called, something like that. And this is at 2, and this is 2, and this is x, and this is x. Okay? Somehow it works like that. I don't fool with those squares and stuff like that. But if you want to find the area, you multiply the length times the width, and you end up with this guy. Okay? So that's what you're doing. Same thing with a square. That's 6 by 9. Breaking it up into its sides or its factors. So that's what you're doing when you factor. Now, you can go with a bigger type of something like 2x squared plus 4x plus 8. Now, when you see one like this, there's two options, or 3 options. 1, do not pronounce this, but FOCT, factor out a common what? Term. Or a shortcut. Put question mark beside that because you can't take the square root of 8, so it's not a shortcut. But you could factor out a common term, and then it would be what? A 4, and can you take the square root of 4? So it might be a shortcut. And then, of course, the last thing would be reverse FOIL. And in this case, I'm going to factor out a common term and see what we get. Because factor out a common term is always your first thing to try. Unless you're doing complete the square or something like that, and then it's just easier just to go through and do it than it is to factor out a common term. X squared plus 2x plus 4. Now here, you think you might have a shortcut number 1, but you don't. Why? Because in order to see it as a shortcut, you have to take the square of the first term, the square of the last term, and multiply it by 2 to see if you got the middle number. So what is 2 times x? 4x. So you don't have a shortcut. You got 2x in the middle. So it's not a shortcut. We've done factor out a common term. It's not a shortcut, so that leaves us with reverse FOIL. We may not be able to factor. 2 times x times x, 1 and 4, 2 and 2. Will 1 and 4 ever give us a 2? No, it will give us a 5 or a 3. Will 2 and 2 ever give us a 2? No, it gives us a 0 or a 4. So that's your final answer. So that's a case of factoring out a common term, and then that's it. You can't do anything else. Now, what if you can't factor? Of course, y'all that had me last semester, you know what to do when you can't factor it. You quit, right? X squared plus 7x minus 2 is equal to 0. You want to find the x-intercepts. So my class, what do you do besides quit and throw your pencil down? What do you do? You can't use reverse FOIL. You can't use a shortcut. Come on. Huh? No. It's still an algebra. We ain't in calculus yet. Complete the square, exactly. So complete the square. Those of you that's in my class, you should be able to do it. If you can't, keep your mouth shut. Those of you that wasn't in my class, you can just sit there and meditate. Or if you still know how to do it, go ahead and do it. Those of you that wasn't in my class or Dr. Marshall's class, you just might as well quit. Go ahead and drop the class. I feel like drop slip after class. Move the 2 over and add your blanks. Okay, hold on a second. Let's change this to an 8. Because I want to start off easy, okay? I don't want to. Okay, it's time for the board to start screwing up. Okay, so x squared plus 8x plus blank is equal to 2 plus 1.
You know what you should do?
What?
You should send some of your videos over to Epson and
I have tried to contact Epson and I have tried to get them to come in and show us how to do this. Well, I contacted IT and gave them the name of the Southeast Regional Training Executive or whatever, and IT never called them. So.
you should send them a video of one of the classes that show all the pain.
And say, help! Yeah, you're right, I should. Well, it is doing a little bit better because I did put new batteries in. I asked for new batteries and I put new batteries in, so that's a good thing. It's working better with that. All right, so what I did, for those of you that have forgotten how to do complete the square, I brought this over. That's what I did here. And then I added blanks. And now I'm going to complete the square. 8 divided by 2 and squared. Well, 8 divided by 2 is 4. 4 squared is 16. And now, when you complete the square, you will have shortcut number 1 or what? Or shortcut number 2. That's why you complete the square. On the left side, you will have shortcut number 1 or 2. And some of this knocking some cobwebs loose. Good. X plus 4, quantity squared, is equal to 18. And now, for those of you that want to finish it, tell me what the vertex is and find the x-intercepts. Those of you who don't, just sit tight and that's what we do.
I was in Albany and holding too much stuff and just fell and this pop came out, so I was squished. I got a ice cream from the 2 days.
Is that a S6?
Yeah, that's good.
That's cool. I tell you, I love my S6. I ordered an S7 for my own Christmas present, and I don't like it because it won't do direct connect. You know, the walkie-talkie for Sprint. Huh? No, it's the S7 something something something. It's something different from the one that caught on fire. At least that's what they told me. But my S7, the one I just bought, I got for $200, is sitting at home, and I'm still using my S6 because I love the S6. That's through Sprint business account. Anyway, I love my S6. I don't do iPhones because they tear up too easy. My son and daughter both they switched. My son hasn't yet because he hasn't paid for his yet, but I let my daughter pay for hers whenever it broke or whenever it was something was wrong with it. And she said she wanted to try the S6.
Your son's what, 10?
There's a reason he has that phone. I'm not going to get into it, but it has something to do with the divorce.
No, I'm just saying that,
Yeah.
I wouldn't expect him to pay for it.
Oh yeah, he wouldn't. So when he gets to be a teenager and he starts working on the farm and getting money, he'll start paying for it. So anyway, I love my S6. I don't like the S7 because I can't do the walkie-talkie on S7. And my mother, she loves the walkie-talkie, and that's the way she contacts me. So anyway, I'll show you. So we got two ways to go here. Vertex, take the opposite of both, which would be -4 and what? -18. So that's your vertex. And then go over here and solve for x. And that'll be x plus 4 quantity squared is equal to 18. Take the square root of both sides. And that's going to be x plus 4 is equal to the square root of 18. Let's go over here. The square root of 16 is equal to 4. The square root of 25 is equal to 5. 4.5 is in the middle. So the difference between 16 and 25 is what? 9. 9 is 4.5. So that's going to be the square root of 20.5. And 16 to 20 is 18, so the square root of 18 is probably going to be somewhere around 4.3. Somebody check me. And then x is equal to positive or negative 4.3 minus 4. So our vertex, our x-intercepts, 4.3 minus 4 is 0.3. So that's one x-intercept. And -4.3 minus 4 is -8.3. Somebody tell me what my y-intercept is. -2. So I want y'all to graph this right quick. You don't have to use graph paper. Just draw a sketch of it right quick so you'll know what it looks like. So -2 is right here. -4, -18. X-intercept is 0.3. And -8.3, well this is 4. The 8 would be over here. And of course, line of symmetry. Line of symmetry is equal to -4. And decreasing from negative infinity to -4, increasing from -4 to infinity. Domain is all real numbers. Range is from -18 to infinity. All of that you can get with complete square.
What was it that thing that
The x-intercepts. 4.3 minus 4 is 0.3, and -4.3 minus 4 is -8. Now, a lot of people say, well, Hubert, you're supposed to do it in radicals. Walk up to an engineer and say, I need to go square root of 4.3 feet. They'll look at you like idiots. There's no sense in studying calculus and studying algebra when you're going to get a non-real number or an unreal solution. Fix it to where you know what you're talking about. So That's why I did this. That's why I did this. Now if you want to leave it, then that would be the square root of 9 times the square root of 2, which is 3 times the square root of 2. Okay? And you fix that however you do with your answer. I'm not going to worry about that. I'm worried about you understanding what the answer is. Okay? The answer, the real solution is right here. Okay? Now that's complete the square, but if you can't factor it, you complete the square. If you can't use a shortcut, you complete the square. Let's do one where it's not so simple. Now, of course, y'all remember, my Calc 1 students remember doing, 10 or 11 different difficulties? Remember doing those? Well, we're going to do number 2 or 3 right now. Anybody got questions? Anybody need any refreshing on this or what I did? Everybody good? The vertex is always the opposite of this guy and the opposite of this guy. Now, the vertex form is written like this. F of x, you take the 18 and bring it over and say f of x is equal to x plus 4 quantity squared minus 18. Now that's what we call the intercept form. And there you take the opposite there and you just bring this down. So you may have seen it like this. I don't usually, I show this and I say, okay, students, that's the way you need to write it for the book. But the easiest way to remember the vertex is to take the opposite of both of these numbers.
You have 203 equals -1 at the same vertex.
LOS, line of symmetry.
Okay.
Line of symmetry, which always goes through your vertex. And your decreasing is from negative infinity to -4, and increasing from -4 to infinity. And the domain on all quadratics are what? All real numbers. Range is equal to -18 to infinity. Now you just have to use your imagination right there because you get near the edge and start doing something. -18 to infinity. All right? Two x squared minus 3x plus 7 is equal to 0. And after we do this one, we'll move on to something else. Let's see, while y'all doing that, attendance. Mr. Will. Oh, Ahmed, sorry. Any one of y'all wasn't here. I think got missed up because Mr. Patel wasn't here Tuesday or whatever day this is. What is today? Thursday? Okay. Mr. Patel was here Tuesday. So the only person missing today is Mr. Scobie.
So you're going to take that one and use another point versus something and do it. Also, I'm trying to figure out who I can turn on and not do it.
Give everybody a couple more minutes. Be nice to know what these are. Maybe I'll learn that in training. No, it's not anything to do with that. What's that? What? What'd you say? I don't know. That would be nice. You need training.
Okay, what was that?
No? How is that? What gets me is it's got crosshairs on it. And it's got a place right here for something to go into. Well, maybe one day when I get training, I'll find out what that is. That's what I was thinking. Put strings on, like straight, like on carpenters. Good gracious alive! Look at all. All right, so we got to factor out a 2 first. So we're going to factor out a 2, and that gives us x squared minus 3/2 x plus blank is equal to -7 plus 2 times blank. Now, for those of you that's refreshing on this, anytime you factor out something, you need to compensate for that 2 right here. You need to multiply by that blank. Now, there's several ways to show completing squares. Some people show it doing everything on the left-hand side, and that's why, since you factored it out here, you have to multiply, because this is really supposed to be over here, but I won't show it that way because most students get confused. So just take my word for it. You factor out a 5 here, then you got to multiply by 5 here. You factor out a -2 here, you got to multiply by -2 here. Whatever you factor out right here, you got to multiply by this blank. Just take my word for it. Now we do completing the square. So we take 3/2, divide by 2, and multiply by itself. In fact, I'm going to do something different. 3/2 divided by 2/1, and multiply that by itself. Now, the reason I changed it to 2 over 1 is we're dividing a fraction by a fraction, or a fraction by a whole number. So I changed it into a 2 over 1, so you remember to multiply by the what? Reciprocal, Hubert. Thank you, class. Appreciate the interaction. Nine what? As in the range. 9/16, which is the range above 1/2 and below 5/8. So you want to say, what's a wrench? It's your parents' fault. All right, finish it. Sketch it. Show me what the increasing, decreasing domain and range are. Because if you can do all that, then you're good on completing the square. Anybody plan on going to see the Bye-Bye Man? I want to go see it. I see him, but want to go see it. Better than the Tall Man. The one that really freaked me out was that one that's in the video camera. I can't remember the name of that one. That one was freaky. Dressed up in a suit and tie and had a white face. Huh? I can't remember the name of the movie.
We just watched a movie called Phoenix Incident, and it's not scary until maybe when you're at home by yourself at night.
And the cat's picking up the guitar.
Thinking outside, walk on doors.
I don't care what anybody says. You have a cat picking up the guitar at 3 o'clock in the morning, that's going to get you up. If I'd have been a bad person, I would have shot the cat, but I love cats, so if it'd been a dog, I would have shot it. But I wouldn't have a dog in my house. So that gives us 2 times x minus 3/4 quantity squared is equal to, okay, you're supposed to shut down now because it's got a fraction in it, and this is where you quit, right? So the 2, that's 2 over 1, the 2 will cancel this into what? An 8. So that's 9/8. Change this to, what's 8 times 7? 56 or 48? 56. Negative 56/8 plus 9/8. So we'll go ahead and let everybody look at that for about 15 minutes and be totally lost because I used fractions. Let y'all let it soak in. Don't be afraid to ask. I know somebody has a question there. Negative 56 plus 9 is negative 47. Somebody help me out.
Yes.
We'll take this over to the next page. Now at this point, you find out something interesting. Let's see if I can do this. That would be a no. Oh well, I'll just copy it and take it over. Where's my box? I guess it's disappeared. It's supposed to be a box on here. Here it is. Oh, box disappeared from me. Suck. There it is. Copy. Oh, you know whose fault it is? It's the Russians' fault. And then it's Bush's fault after the Russians. It's the Russians' fault first, and then Comey's fault, and then it's Bush's fault. Okay, now it's not going to erase. Oh my Lord. Glad I had training. I should have just wrote it over, but oh well. Mr. Bradshaw and Huth, you still with us? I told you they were going to pass out.
Oh yeah.
Which one's that one?
Oh, it's Aaron.
Okay, Mr. Huth, you still there? Mr. Huth's trying to find his car. Ain't there a movie called Hey Dude, Where's My Car? We all know what Mr. Huth was doing the other night. Lost his car. All right, let's take our highlighter and highlight this, because that tells us what? That's a good political answer. Maybe. Mr. So-and-so, what do you think about maybe? It's important. All right, what does it tell us?
It does us one vertex, one vertex.
Yeah, it does that, but besides that, what does it tell us? Thank you, class. No what? Why? It's negative, and you can't take the square root of what? Negative. So that means no x-intercepts. Now, this is the common sense answer. That's not what they're going to ask for in the book. So I need to go ahead and show you what to do. You got to use I. So the vertex is 3/4, comma, 47/8, whatever that comes out to be. 8 will go in there, what, 6 times is 48, so that's 5 and 7/8 or something like that. And now we're going to finish it. So divide by 2, x minus 3/4 quantity squared is equal to negative 47/8 divided by 2 over 1. I was dividing by 2 on both sides. And it's going to give us x minus 3/4 quantity squared is equal to, multiplied by 1/2. It's going to give us negative 47 over 16. Now, those of you that can remember what to do with the negative as far as taking the square root of it with I, go ahead and finish it. Write it in terms of I. For those of you that's going to meditate, let's meditate on, and we will finish it after meditation. I think I remember some of this from last semester. I'm impressed. Mr. Huff, you there?
Still trying to start.
Square root x minus 3/4 is equal to the square root of negative 47 over 4. X is equal to square root of negative 47 over 4 plus 3 over 4. X is equal to the square root of 47 times the square root of negative 1 plus 3 over 4, because these are common denominators. I'll put it all over 1 4. And then what is the square root of negative 1? I. So x is equal to I times the square root of 47 plus 3 over 4. Now this is the answer that you're going to get in your book or on a test that's asking you to write it in terms of I. This is what it really tells you, that you don't have any x-intercepts. So go ahead and with the y-intercept and the vertex, go ahead and sketch out the function. Well, yeah, it's right here, but it doesn't matter because you left the radical. If you took the square root of 47, it would be plus or minus whatever. What's the 40? Square root of 40. What? 36, yeah. So it'll be positive or negative 6.5 or something like that. But I didn't take the square root, so you don't need the positive and negative, because it's a non-real number. In other words, you've got a function with a y-intercept of, I don't forget what it was. What was the original problem?
2x minus 3x
Plus 7, so you got a y-intercept of 7. And 3/4 is this way, and 5 7/8. So this don't have an x-intercept. It doesn't cross the x-axis anymore. And of course, the line of symmetry is right here. The domain is all real numbers. The range is from 5 7/8 to infinity. Decreasing is from negative infinity to 3/4. Increasing is from 3/4 to positive infinity. Capiche? Yes, Hubert, we understand. Thank you, class. You want to do another one?
You figured out the y.
No means yes, right? What'd you say?
You just used 7 as the y-intercept.
Yeah, the C is always the y-intercept. Let's do a negative, and then we'll move on. Because that way, that will cover pretty much all 3 types of complete square. And Miss Grant wants to do another one. Right? Sure. Negative 3x squared plus 5x minus 2 is equal to 0. Anybody thirsty? Oh, ask somebody to need something to drink. That's all right. Forgot my drink. It's on the cabinet. Fix me a nice big old cooler of Jack and Coke and forgot it. Man, if I brought, that's what gets me. Some of these teachers, they can bring their red Solo cup and drink during class. If I did that, I would be stopped in the parking lot. I don't understand how these people get away with that. They're Russians. That's what it is. I said that in one of my classes, and they said, "Why do you keep blaming the Russians?" I ain't kidding you. Our society has gotten totally stupid. They don't watch the news. They don't pay attention to the news. They don't pay attention to current events. And they walk around, and they're going to be on TV one day online, and somebody's going to ask them, who's the President of the United States? And they're going to say George Washington. Why are you blaming the Russians? Finally, one of the Hollywood actors, was it Madonna, that came out and said that Hillary lost because of the women of the United States. This is coming from somebody that said that, did you hear what Madonna tried to do to get votes for Hillary Clinton?
Supposedly,
No, I saw it on TV. I saw it online. I don't know if she actually did it or not, but she said she offered sexual favors for anybody voting for Hillary.
If she were to do that, she would be busy for 10 years.
Yeah.
And
That shows you how screwed up Hollywood people are. Not all of them. I mean, there's always Denzel Washington. He's pretty good. He don't say anything about politics. He's smart. When you're in Hollywood, you shouldn't say anything about politics because you shouldn't. You should keep your opinion to yourself.
they're saying a lot of people should say them because they don't look like the average person.
No,
So
they don't. And kudos to them. They worked hard to get there, and from what I hear, that is not a good and easy place to get. It's not. Some of them have to live like that, and I just don't know if I want it. But some of them handle it classy, some of them don't.
If you bring the negative 3 on the website, it brings the positive, or is it to send it?
You don't bring the negative 3 over, you bring the negative 2 over.
Well, yeah, but we're going to multiply the negative 2 or the 2.
Yeah, well, yeah, whatever you factor out, doesn't matter. You bring it over to the other side. You don't change it, you just multiply. You factor out a negative 3, you're going to multiply by negative 3. So 25 over 36. what I got. Y'all see if y'all come up with the same thing. And of course, I want you to pull out, after you do this, I want you to pull out your graphing calculator. And I want you to type it in and graph it, see if your graph looks like the calculator. Okay? Check it, make sure it's right. And if it's not right, then that means you're wrong. Failure. You're going to get it down. I bet Dr. Marshall didn't call you failures, did he? This is long. One day I'll tell you all the story about the failure. For those that don't know it. It's a joke, sense of humor. You know, something we hadn't had in the last 10, 15 years as a nation. You know, sense of humor. Ha ha ha. I'm offended. Oh my gosh, did y'all see the press conference yesterday? Anybody see that? Of course not. Y'all don't watch the news. President-elect Trump went off on CNN's reporter and just told him, get out. It was so funny. But you got to understand what happened. Yesterday morning before the press conference, CNN reported a fake story. It was fake. Everybody says it's fake. New York Times said it was fake. They didn't collaborate it. They didn't check it to see if it was, CNN just threw it out there and said that President Trump is terrible, most awful thing in the world. And they got caught on it. And it was BuzzFeed and CNN. So yesterday's press conference, the CNN guy raised his hand and said, and President Trump picked the guy on the left of CNN, the guy on the right, the girl on the right, the guy in front of CNN, and the guy behind CNN. And the CNN guy said, President-elect Trump said something about CNN being a piece of crap, basically. And that guy stood up and started hollering, saying, why won't you give me a question? Why won't you give me a question? He said, because CNN is not a good station, or not a good news outlet, and you are fake news. And he just kept on hollering, and finally they finally settled him down, and I thought it was great. I hope he does. I hope whoever did that story gets fired. Because that's what's called propaganda. It's when you don't report the news, and if you don't report the factual news, that's what you call propaganda. And the news that the true news, the real news, they don't report. But you gotta watch the news in order to understand it. All right. So, what does this tell us? Be careful. Does it say no x-intercepts? No, because you're going to divide by -3, and what does that make this over here? So you're going to have x-intercepts. Now, the reason I showed this type question is so you don't get wrapped up in the negative too much. Just make sure that if there's another negative over here, then you're going to have, and there's a negative there, you're going to have x-intercepts. Okay? So the vertex is equal to 5/6 and 1/12. And now we're going to solve for x. Divide by -3. Divide by -3 over 1. So these cancel. So I'm just going to cancel those out. And then multiply by 1 over 3. And that's going to give me 1/36. So x minus 5/6 quantity squared is equal to 1/36. Take the square root of both sides, you get x minus 5/6 is equal to 1/6, positive or negative. And then x is equal to positive or negative 1 minus 5 over 6. And we'll finish that right over here. So your x-intercepts. So what is 1 minus 5? Negative 4 over 6 is negative what? 2/3, which is negative 0.67. What is negative 1 minus 5? Negative 6, Hubert. That's right, class. Negative 6 divided by 6 is negative 1. So let's check to see if it looks right. My vertex and my y-intercept is negative 2. My vertex is 1 in the x direction, technically, and 1/12, which is a little bit over the and I know something's wrong. Why do I know something's wrong? Because it's not lining up. I have two negatives. The two negatives are over here, like that. Something's wrong. It should be, the vertex should be over there. I must have something wrong with the vertex. There it is. Right here. Okay. Should be negative 1/12. Yeah. Okay, somebody tell me where I got it wrong. Somebody check this. The vertex needs to be on that other side. Why have I got it wrong? Should be negative 5, 6. Oh, did I take the opposite? Yeah, I took the opposite. Okay, somebody find it. I got something wrong. Graph it on the calculator. There it is. Thank you. Now, I did this on purpose because when you draw out, I'm not worried about making a mathematical mistake, because when you draw out, sketch it out, you're going to what? You're going to catch it, just like I caught this one. Okay, so now it's going to be 1 plus 5 is 6. 6 over 6, so that's going to be a positive 1. And then negative 1 plus 5 is 4, so that's going to be a positive. So now it looks better. 0.67 and positive 1, which is right in here. Something like that, because that's 7/8, so it looks something like this. All right, now check your graphing calculator and check to see if it looks like that. Now, domain is what? On a quadratic, domain is always what? All real numbers. What's the range? The range is from negative infinity up to what? Up to y, which is 1/12. And then increasing from negative infinity to 5, 6, decreasing from 5, 6 to what? Positive infinity. Line of symmetry going through x is equal to 5, 6. All right, who's got questions on complete the square? Let me ask Mr. Bradshaw, you had Dr. Marshall?
Yes, sir.
You good?
Yep.
Okay, did y'all go over complete the square a good bit?
Yeah, we did.
Okay, how about anybody else? Oh, now my students, y'all shut up because y'all had enough. How about you? You hadn't did it. Okay, that's good. All good? Okay. All right, so complete the square is good. Let's move on to rationalizing the denominator, because rationalizing the denominator is very important in calculus. So let's just do a couple. Let's start off with 2 over the square root of 2. And let's do 3 over the cube root of 4. And then let's do x over the square root of x plus 3. And then we'll do 3 over I plus 4. Okay, all of these have what in the denominator? A radical. Okay, all of them have a radical or a square root symbol in the denominator. Now, in limits, we know that sometimes when we're doing limits, we don't want a radical in the denominator because you can't get the limit to come out exactly right. So what we do is we throw the radical in the numerator, or vice versa. Okay? So, with the first one, you've got to find the perfect square that goes with the square root of 2. What is the perfect square that goes with the square root of 2? Well, you can take the square root of 4, can you not? The square root of 4 is 2. So you multiply by the top and the bottom by the square root of 2, which is what this guy is right here. And that gives you 2 square root of 2 over the square root of 4, which is equal to 2 square root of 2 over 2, which is equal to the square root of 2 over 1. So I have moved the radical that's in the denominator to the numerator. And that's what you're actually doing. Now sometimes when you get in Calc 2, 3, get the cube, sometimes you're going to move it from the numerator to the denominator. There will be some applications, but not very many times. Most of the time you're going to move the numerator, the denominator to the numerator. All right? What's your first cube root pertaining to 4? Huh? No. What's the first cube root? Cube root of 1. Okay. Cube root of 8 is what? 2. So I'm going to multiply the bottom by the cube root of 2, the top by the cube root of 2. Now the biggest problem students have here is they're still thinking in terms of square roots. You're not. You're thinking in terms of cube roots. Cube root of 2, cube root of 2. What is the cube root of 2 times the cube root of 4? Cube root of 8. And 3 times the cube root of 2. And the cube root of 8 is 2. And 3 cube root of 2. And that's your final. You have to think in terms of what? The cube. You could do 64, but if you just have extra what? Work, you have to reduce at the very end. Now these two guys are going to use the conjugate. I hope I spelled it right. Okay? C-O-N-J-U-G-A-T-E, conjugate. Conjugate means opposite, or the opposite operation. A plus B, the conjugate of A plus B is A minus B. The conjugate of A minus B is A plus B. So if you ever want to get rid of a radical in the denominator, and the denominator is a sum or a difference, you use the conjugate, because that will give you, shortcut, number 3 in the denominator. Sorry. Minus. And it'll help if you write the problem down right, Hubert. There. So the conjugate of x plus 3, or the square root of x plus 3, is x minus 3. And then, of course, when you do that, this right here gives you shortcut number 3. With shortcut number 3, a plus b times a minus b will give you the square root of x quantity squared minus 3 quantity squared over x times square root of x minus 3. And what is the square root of x squared? And what is 3 squared? And again, you have transferred the radical from the numerator, from the denominator to the numerator. These are just manipulation drills. All of this is manipulation. All calculus is manipulation. Taking something, taking a problem, taking it apart, putting it back together in a different way. That's all you do. That's why you take 3 or 4 semesters of differential equations and calculus. Not because anybody is going to walk up to you and ask you any of this stuff, but you need to be able to take a problem, whether it be human resources, whether it be engineering, take a problem, analyze it, break it up, find the problem, find the problem that's causing the mess up or whatever, and fix it. That's what you're doing. And that's why engineers have to take 3 or 4 calculuses, 3 or 4 physics. Not that anybody's going to walk up to you and ask you the derivative of 4x, but they're going to ask you to take something apart. Now, you don't have to take it apart physically. I mean, there's a problem, let's say a mechanical problem in a Michelin plant somewhere, and you're the engineer and you're trying to figure out what the problem is. Well, the first thing you're going to do is define the problem. The second thing you're going to do is take it apart on paper, and you're going to try to figure out what the problem is, and then put it back together. And that's manipulation. That's what you're doing. This is some of the factoring and some of the first manipulation that you're doing. Rationalize, manipulation. Taking something and rewriting it in a different way. That's all it is. So do the last one and see what you come up with. Huh? I squared is -1, right? So it'll be I squared is -1 plus, it'll be -1 plus 16, won't it? It'll be about 15. I don't know. I'm just doing it in my head. So it'll be I minus 4 over I minus 4, which will give us 3 times I minus 4 over I squared minus 4 squared. And I squared is what? -1. So 3 I minus 4 over -1 minus 16, -17. 3 times I minus 4 over -17.
So you can just change the I to -1. That'd be too easy.
Yeah. And what did I tell you about too easy? Does calculus and easy go together?
No.
Remember me telling y'all the comment or the thing that goes on? You got 2 here and 4 here and x here, and the teacher says find x, and the student goes, here it is. Y'all see that? Is it that easy in calculus? No. Now, you may think the problems are easy, but nothing is going to be that easy in calculus. There's going to have to be some algebra. There's going to have to be some manipulation before you can get the answer. Nothing is that easy in calculus. So, you're getting there and you're saying, that's just too easy. That ain't going to work. If you say that, then you're right. Okay? All right. 3 signs on the board. 3. Okay. Now, what else did it say go over? I know logarithms. I know that. We're going to do that today. We're going to go over. Let me look and see. I had it pulled up. Oh well. Let me pull up the. What day was that? Friday. calculus. Okay. Exponentials, I don't think I need to go through exponentials. Radicals, logarithms. Yeah, get you one too. Get me a Sprite or a ginger ale or something.
Okay, sure.
The exponentials, well, I'll go over that right quick. It's not really a big deal. I think y'all know the exponentials, but I want to cover everything so that way you can't say that I didn't cover it. And blame it on the Russians. Let's go with the exponential laws. That's why the exponential laws apply to the logarithmic laws. So that's why they won't go over it. So, wait, is something wrong? The exponential laws the product rule. The product rule says, I don't look right, product, is it still right? Product rule says a to the n times a to the m is equal to a to the n plus m, meaning that you add the exponents and you multiply. The quotient rule, a to the n over a to the m is equal to a to the n minus m, meaning that you subtract and you divide. And that's going to play over to the logarithmic rules also. The power rule says a to the n raised to the m power is equal to a to the n times m, meaning that you multiply whenever you raise an exponent to another exponent. The inverse rule says that if you have a power with a negative exponent, a term with a negative exponent, that you can flip it, and it becomes a to the second over 1. It's supposed to be n or m, but I'm using a number. And if you have a to the negative 2 over 1, you can flip it, and it becomes 1 over a to the second. So it works both ways. Okay. The inverse power rule says that if you have a exponent outside of a parenthesis, a to the n over a to the m raised to the negative w power, that you can flip what's inside a to the m over a to the n, and it becomes a positive exponent. Okay? Now these two are kind of for aesthetics, to make a positive exponent. Okay? They're for mainly aesthetics reasons, and some people don't like to multiply by negative, so they'll turn it around to make it a positive and flip it. So these two are mainly for aesthetics. These three are the workhorses as far as the exponential laws. Okay? Mostly this one and this one, these two work a lot. All right, so exponential laws give you the logarithmic laws, which say the product rule, log base 10 of a times b is equal to log of a plus the log of b. In other words, if you have a logarithm with two terms and multiplying, you can divide it up into addition, and vice versa. If you have addition of two separate logarithms, you can combine them as a multiplication, a product. Same thing as the quotient rule. The quotient rule says if you have a division term with a single logarithm, you can write it as two separate logarithms. And if you have two separate logarithms that you're subtracting, you can write it as a division, as a quotient. Now you're going to see the power rule a good bit in calculus. Power rule of logarithms. Power rule of logarithms says that if you have a exponent outside of a term of a logarithm, and I'm going to just say a to the n, that you can bring that n out to the front. And vice versa. If you have a n out front and you want to write it as a without something in front, you can bring that n out here and put it on the page. And of course, a lot of these should be kind of review for you. It should be knocking the cobwebs loose and all that good stuff. And the only other one I want to show you right now is the change base formula, which says log base A of B is equal to log base 10 of A over log base 10 of B. That's a change base one. And we'll be going over those whenever we, main thing is when you see these in the homework or review homework, you'll know what to do. Hopefully, if not, just let me know. And we'll go over it whenever we'll come back Tuesday, I think. Today's Thursday, Tuesday. Okay? Now, the trigonometric, I'm not going to spend a lot of time on trigonometrics because trigonometrics is basically memorization. So what I'm going to do is get out of this. And I'm just going to show you the best thing to do is go to Google. And just type in trig identities, images, and there's a green one that I usually use, but it's not there, so disappeared. Well, there's plenty that you can print out. There was a green one that I always used, but it didn't pop up this time. There's one that you can, of course you need to blow it up a little bit, print it out and blow it up, or you can go, they offer cheat sheets in Trig that are laminated. That would be a good one to have. Like I said, they usually pop up with a good one, but looks like that. There we go. They changed the color of it, I guess. I don't know. But that's a good one right there. And I'd rather you just take that and use that. You need to pull up the derivatives. So do that also. Just type in derivative or trig derivatives. And integrals. Thank you, ma'am. Well, that sucks.
I tried yours, I tried mine, I went and go look for change.
Don't worry about it. Don't worry about it. I'll go get you something during my break. I didn't know it didn't take. You don't have a swiper?
It does.
Oh, it's just not working.
It's not taking it yet.
Okay.
And it's not the card.
No, it's not the card. Sometimes those things, it says sending and it never does send. It just locks up in a loop. Okay.
The guy said they were either, so.
Okay, here we go. Here's derivatives. There's derivatives, and then pull out the integrals. Let's see, I'm looking for the integrals. I got them. Here we go. No, that's the inverse rule. Sorry, that's the. Do y'all see the integrals? Here it is. There we go. There's the integrals. Derivative of the antiderivative of the sine is the negative cosine. The antiderivative of the cosine is the sine, and so on. I'm not gonna. There's a better one than that. Good gracious. Well, they know how to confuse people, don't they? Well, what I'll do is I'll find. Here we go. There we go. Perfect. You need that also. The derivative of the sine is the cosine. The antiderivative of the sine is the negative cosine. So you might want to make a note of that. I'll pull that up Thursday for you if you don't have it. But go to Google and pull up your antiderivatives and your derivatives right there that I pulled up, and pull up your identities. And we'll do some of those Tuesday, okay, when you come back next week. I'm going to go ahead and load some homework today for this weekend so you can be working on it, so you can get those cobwebs knocked out, so you can ask questions Tuesday. If you've got something that you don't know how to do, I need to get started on the review process so we can get the review out of the way. Be expecting 2 or 3 sections of review, 1 being algebra, 2 being trig, and 3 being derivatives and antiderivatives, or 4. Okay? And I don't know if we're going to have a test on the review or not. We might, but it won't be nothing but 10 or 15 problems, just something to give you a grade. And then we can move on to the meat, which is the substitution and all that, and get to working on the tanks and water tanks and oil tanks and all that good stuff. Okay? Who's got questions so far? All right, I've already taken the roll, so y'all have a good weekend, and I will see y'all Tuesday, and look for the homework. It may probably be up today sometime. It'll be called Review Algebra, Review Trig, Review Derivatives, Review Integration, something like that. Okay? Yes, Hubert. Okay. Thank you, class. Have a good weekend, class. You too, Hubert. You suck, class. We know. Yes, sir. You haven't? When did you have the class? Like last semester? Or? Okay, you need to check with 1779 and make sure your email's working, because I sent them out.
Okay, well, I need another email.
Let me check and see right quick.
Same thing happened last semester with this class too.
Let me check, see if your name's on there. If it's not, then I don't know what. Well, all I do is copy it over. Let's see. All right, do you see your name?
Yes.
I don't see it. Oh, wait a minute. Hold on. I gotta shift it. Okay, Mr. Bradshaw, have a good one.